Hello, my name is Professor Johnson, and today we will discuss hypothesis testing. Hypothesis testing is one of the best tools statisticians have to make decisions. So, to start with the decision-making process, we first need to start with some kind of statement that we want to test. And truly what we're going to set up are two contradictory statements. And we're going to sample and then build evidence either for something or maybe against something. So first let's talk about what the null and alternative hypothesis truly all are. So symbolically, the null hypothesis we will label as H0 or H0 or HO. HO is typically what you'll hear it called as. So I'll call it HO because it's easier. Now the alternative hypothesis, we will call that HA. A for alternative. Now HO and HA have to be contradictory statements. Alright, so let's start with an example. Doctors at a clinic claim that at least 80% of their patients are satisfied with their quality of healthcare. A competing clinic wants to show that this is not true. Now, HO and HA are going to be statements about the population parameter. Now, the population parameter in here, if we look at the 80%, this is telling me that we're dealing with proportions in this example. And with proportions, I'm going to think of P. So let's start with HO and HA. In HO and HA, I know that I'm going to be making some kind of statement with the population proportion P, right? The population parameter, for this case, it's proportions P. Now, the doctors are claiming that at least 80% of their patients are satisfied, and then the competing clinic wants to show that it's not true. Okay, what we want to show usually goes with the alternative. So what we want to show that this statement, at least 80%, is not true. So you see how these are contradictory of each other? The claim and what we're trying to show are contradictory to each other. Now, the doctors are claiming that at least 80% of the patients are satisfied. So this is saying that P is at least 80%. So P is greater or equal to, and I will convert the 80% to 0.8 in decimal form. That's our proportion, and contradictory to that would be P is less than 0.8. Alright, so that would be our null and alternative hypothesis. The next step would be to collect data on, probably the patients in this clinic and see where we go, and we'll have to do some extra testing. Okay, so that's the first example. Now, in number 2, the tutoring center wants to show that the mean number of users per day is more than 100 users per day to receive more funds. Okay, so we want to make a decision for the tutoring center and see, okay, from their data, will they have enough to show that the mean, the population mean, is more than, greater than 100 users per day. So we want to find HO, HA. These have to be contradictory. Now what we want to show, or what we're trying to test, is that the mean, and the mean, the parameter, the population parameter mean would be a mu. So we will be using mu in this example, and we want to show that there are more than 100 users per day. So I'm going to put 100 here and 100 here. Now, the alternative hypothesis will go with what we're trying to test or what we're trying to show. So I want to show that you have more than 100. the null hypothesis has to be contradictory to that. So mu would have to be less than or equal to 100. Sometimes you'll see in books that they may just say mu is equal to 100 in the HO. Same thing up in number 1. It's possible that they may have just said P is equal to 0.8 and then you'd look at less than 0.8. It's possible to see that in some books, but I will just show it straight up as a contradictory statement. Okay. Now, in number 3, we are interested in testing if the average number of years it takes community college students to graduate is 2 years. Okay, and some keywords here. Average number. So when I think of average, I'm thinking of mean. So I know mu is back in play. I do not have a proportion like number 1 had proportions. This is an average that we're looking at of 2 years. And it says is 2 years. When I read is 2 years, I think of equal or equals, right? Equals 2 years. So let's start HO, HA, the null hypothesis and alternative hypothesis. Now, like I said, we're using mu and we're interested in 2. Okay. And we want to test if it is 2 years. Now, I have to make a point that the null hypothesis always has an equals in it. As you can see in number 1 and number 2, the equality, the equal sign is in the null hypothesis. In the alternative hypothesis, you never have an equals. You never have an equals. As you can see, in number 1, it's a less than. In number 2, it's a greater than. In number 3, in order to not have an equal, we will put a not equal to. And there we go. That is our null and alternative hypothesis for number 3.